let us do a bit of geometry. Let us assume that we have a quadrilateral in a two-dimensional plane. And we intend to prove that if we connect the middle points of every side of this quadrilateral, we get a rhombus. It is a very well known result of geometry, which we will try to prove using vector algebra. This is very simple. Just remember that if we replace A by A1 A2, B by B1 B2, C by C1 C2 and D by D1 D2 as their respective coordinates, we have the vector representations or the position vectors of A, B, C and D, and they comes out to be A equal to A1 I cap, A2 j cap, B equal to B1 I cap, B2 j cap, C equal to C1 I cap, C2 j cap and D equal to D1 I cap plus D2 j cap. This is about simple formation of vectors. We all know this. Now, let us nomenclate this as E, F, G and H. Remember that E is the midpoint of AD. So, what will be the coordinate of E? It will be A1 plus D1 by 2 and A2 plus D2 by 2. We all know that from our idea of coordinate geometry, A2 plus D2 by 2. So, now forget about this figure and let us do the algebra. So, what we have? We have these 4 vectors pointing out the position vector of A, B, C, D of the quadrilateral. Okay. Now, what will be the position vector of the midpoint of AB? We have written it as E, is not it so? So, what will be E? The position vector of E, that will be obviously midpoint of A and B. So, it will be A1 plus B1 by 2 I cap plus A2 plus B2 by 2 j cap. Okay. Next, we have F, then there G and then there H. So, what will be the position vector of the point F? F is the middle point of B and C. So, it will have coordinate B1 plus C1 by 2 and B2 plus C2 by 2, is not it so? So, this is B1 plus C1 by 2 I cap plus B2 plus C2 by 2 j cap. What will be the position vector of G? Let us write it with small g, is the midpoint of C and D. So, it will be obviously C1 plus D1 by 2 I cap and C2 plus D2 by 2 j cap. Okay. Lastly, we have H, which is the midpoint of A and D. So, what will be H? Obviously, H will be A1 plus d1 by 2 I cap plus a2 plus d2 by 2 j cap. So, we have E, F, G, H. Now, we have to prove that E, F, G, H is a rhombus. So, what we need to do? We just need to do that E, F is equal to F, G is equal to G, H is equal to H, as well as no angle is 90 degree. So, it is very easy. How? Because what is E, F? We know that E, F is the vector F minus E, isn't it so? We know. So, just do F minus E, you can easily find that it will be equal to F G, which is equal to G minus F. And similarly, if we find G H, which is obviously H minus G, that will be equal to H E, which is nothing but E minus H. This is simple algebra. I am not elaborating on it. Actually, when I do F minus E, this B1 cancels out and this becomes C1 minus A1 by 2 I cap, and here B2 cancels out and C2 minus A2 by 2 J cap. And when you do G minus F, this C1 cancels out. So, this becomes D1 minus B1 by 2 I cap, and when C2 cancels D2 minus B2 by 2 J cap, and you can easily establish that they are equal.